someone missed tonight. Okay. Project management. In the video, mentioned a lot of tasks. So when we say project, then sounds like a big one, right? So many tasks, a series of related jobs, and then those tasks, maybe there is a kind of a sequence. First thing, and then next one, and so on like that. So from the video, before we dig the foundation, they cannot build like a pillar or something. So something first, something next. So series or the sequence, there is sequence of related jobs. And then period of time is very important in a project, because if whatever reason, like weather reason or whatever reason, delay the project, then it is cost. So project management, managing activities in project. So for the project, we need planning, directing, controlling resources, and so on. So manage or control, coordinate activities in project to make it better, cheaper, faster. That is project management. In project, the time is very important, and then because of the sequence of each related jobs or tasks, we need time managing is very important. Then in project management, we use network planning method. I think you heard this term, critical path method. So find which path is critical, then manage especially that path. And then another name of network planning models in project management, I think you heard this word, PERT, P-E-R-T. So many cases in project management, you maybe heard or hear PERT and CPM. CPM is critical path method. Then PERT stands for program, evaluation, and review. Technique. The pen doesn't work very much. So PERT, program, evaluation, and review techniques. In our textbook, three critical path methods introduced. First one is critical path method with single time estimate. Second one is three activity time estimate, and the last one is time cost models. Others are CPM. If we have only time information, then we use critical path method. If we have time and cost information about the project and then each activities or tasks cost, then we call that time cost models or PERT, program, evaluation, and review technique. First, critical path method with a single time estimate. Using this method, we can estimate time, determining the project time. And then if time is like certain, such as we know the activity times in certain times, finish in 5 days, 5 weeks, in certain time, then we use this single time estimate critical path method. Example. This example project consists of 7 activities or tasks. Then designation is A, B, C, D, E, F, G. And then here, immediate predecessor. Activity A, task A, doesn't have immediate predecessor. That means this one is the starting point. And then there is sequence. Activity B can start after A finish. And then C after B, D and E after C, and so on like that. And then time for each activity or task. Then when we develop critical path method, some steps. First step, draw network diagram like this, using the information, designation, and then immediate predecessor. So A is starting point, and then B after A. By the way, using node and circle type and then arrow, then we can indicate where that come from. And then certain textbook or other use like a box type for that each draw box or a square type symbol using to develop network diagram. So A, B, after B, C come, and then D and E after C, and then F after D and E, and so on like this. And then step 2, by the way, many instructors, operations management instructors, don't cover this part. When I was an MBA student, the instructor also didn't cover this part. But I told you when I was an MBA student and to do that team project for that course, I developed the school the traffic system using a queuing system like that. So who knows? In the future, you may need this one, right? So anyway, project management. And also, you know, when I was at other school, then the school has had the upper project management course. So I taught that project management course. So in real world, this project management important when like you know this time you do team project for this class, like developing case, that also project, right? So when you do a project, you may need this project management, time scheduling, time management, and so on. So but anyway, I will not give you an assignment from this chapter, just let you know. And then in the future, if you need project management concept or something, then you can recall, and then you can find certain information and so on. So just to give you reference in the future if you need this one. So just feel free just listen, okay? Okay, and then step 2. By the way, you may not need this step 2 and step 3 because in real world we use software, project management software. I will tell about that later. So, but you don't need to figure out what is early start, early finish, late start, late finish. But because the program do this for you if you use software for the project management. But I just show you how it works. Okay, we need early start and early finish time for each activity. So activity A starts from 0 to, and then use 2 weeks. So finish time is 2. And then B can start after A finish. So early start time of B is 2 after B. And then use 1 week, finish as 3, 3, 4, and 4, 6. And here, C after C, D and E start. You know, even activity D finish in week 6, but this one still work. But this one, F, activity F, start F after D and E. So wait until activity E is finished, and then this one can start. So early start time of the activity F is 9, and then use 5 weeks, 14, and so on like this. And then next step is determine late starts and late finish time. To figure out late start, late finish time from the last one backward, so finish time is 15, and the minus 1 is 14, and then goes there, and then 14 minus 5 is 9. And then when we go this way, same, 9, 9, and 7 minus 2, 7 minus 4. And then go there, maybe 7 and 4, that case. Only 1 goes there, and then 3 and so on. I will tell you why they are early start, early finish, and then late start and late finish here. Okay. If I draw a timeline like this, and then here, the project time, total time is 15, then 10, 5, 0. On this timeline, A starts 0 and then finish week 2, and then B starts 2 and then finish 3. And then C starts 3 and finish 4, C. And D and E start 4 and then D finish 6 plus 2, 4 here. This is D. And then F starts 4 and then finish 9. And after that, F starts, finish 14, and then 15, 0 like this. Others are A, B, C, E, F, G. They have only one number, 1, 2, and so on like this. But here, activity D, if activity D start 4 at 4 and then finish 6 because use 2 weeks. If start 5 and then 7, 6 and 8, 7 and 9, and 9, 8 and 10 like this. Because activity E finish at 9 until as long as activity D finish week 9, then there is no delay. So until E finish, so possible combination of start and finish time for activity D, 1, 2, 3, 4. So among them, this is a start time and then a finish time. So among them, early start, early finish, late start, late finish. Without delaying entire project, activity D can start week 4, 5, 6, 7 until 7, as long as finish until E finish. Then entire next activity can start on time. So early start, early finish, late start, late finish. So activity D has a different early start and late start. But others, A, B, C, E, F, G, their early start, late start, and early finish and late finish the same. So if activity A delay, then entire activity delay. B delay and delay, delay, and so on. But activity D can be delayed up to later, 7 minus 4 or 9 minus 6 up to 3 weeks. Activity D can be delayed without delaying in the entire project. We call that slack. Slack is the time each activity can be delayed without delaying the entire project. So activity D has 3 weeks of slack, like a spare time, but others, there is no slack. So in entire project, A, B, C, E, F, G, they are critical activities. If they delay, then project time delay. But this one, even this one is delayed on up to 3 weeks. Entire project doesn't delay. So this one is non-critical activity. Others are critical activity in this project. And then also, there are two possible ways in this project. One path is here, this path. And then the other path is here, this path. So there are two paths in this project network. First path, A, B, B, A, B, C, D, F, G. And then the second one is A, B, C, E, F, G. In this path, this one non-critical, but all other activities in this path is critical. So any activity delay, then project delay. So in this between two passes, this path is critical path. And then this path is non-critical path. So especially manage this path, not to delay this project. So we call this critical path A, B, C, E, F, G. And next one is critical path with 3 activity time estimate. In real world, activity times, they are not certain. Sometimes shorter, sometimes longer, and so on. 3 activity times, there are 3 activity times like most likely time, pessimistic time, optimistic time. Pessimistic time, maybe finish early. Most likely time is like an average kind of late time. So we call this 3 activity time estimate. And then we don't know because times are uncertain. So we don't know exact time, the project time. So using this 3 activity time estimate, we can get probability information about that project. So similar example, there are 7 activities in this project, and then similar immediate predecessor. Using immediate predecessor, we can draw a network diagram. But we don't know the single time. So using this formula, then find expected time for each activity. So using this, A plus 4 times M plus B. Optimistic time A, most likely time M, and pessimistic time B, and then divided by 6. This is kind of weighted average. Coefficient of this one is 1, 4, 1. So 1 plus 4 plus 1 equals 6. So divided by 6. So using that formula, we can get activity expected time for each activity like this, and then use this expected time as single time. Then we can draw network diagram and then find which one is critical path. So after drawing and then calculate early start, early finish, late start, late finish, then we can determine which one is critical path. And for this example, ACFG is critical path, and then duration, project time, expected project time is 38. Then we can get a probability of certain project and finishing project in certain day. You know, this one is kind of average time. And then we can use just a moment. I click something different. Okay, but yeah. Okay. On normal distribution, the duration expected completion time is 38. And then this question, like the probability of completing the project in 35 weeks, about here, in 35. So looks like this. So find this area, the probability. So to find the probability, we need z-score. You know, z-score on average is equals 0. But here, negative z-score, and then this way is positive z-score we can expect. To get this probability, we need z-score, like on the border. Z equals D, that is desired completion time, given time, like in 35. And then T is expected completion time, 38. And then divided by square root of sum of variance on critical path. Critical path of this project is ACFG. So using only ACFG activities variance. By the way, we need variance. So using this formula, variance equals pessimistic time minus optimistic time divided by 6 and square. So using that formula, we can get variance for each activity. And then critical path is ACFG. So use only ACFG variance. And then plug in 35 minus 38 divided by square root of variances on critical path. And then negative 3 divided by square root of 11.89 equals negative 0.869. So approximately negative 0.87. Find that z-score from normal distribution table. Then we may not find the exact number. Then choose closest one. So closest one is negative 0.87, and then the area is 19.766%, 0.19766. That is 19.766%. So the probability of completing the project in 35 weeks is 19.766%. And then we can bring up another question like this. The probability of completing the project longer than 40 weeks, this case, I can draw normal distribution. Then 38 here, and then 40 here. So find this boundaries, z-score, and then longer than right side. So again, we need z-score. So using the formula, 40 minus 38 divided by the same variances on critical path, and then square root. So 2 divided by square root of 11.89 equals 0.58. From the table, 0.58 closer to 0.6. So the area is 0.72575. But the area 38 here, 40 here. This one is longer than, so z equals 0.58. Then the table gives an area is left side. So longer than is 1 minus total area of under the normal distribution is 1. So right side is 1 minus left side given area, and this one. So answer longer than 40 weeks will be 27.425%. Ordinary critical path method using only time information, but if we have cost information, this one is not, I think, not in your lecture notes, but that I just go over. We call this one part. So using cost information, it's like that. If to complete certain activity, regularly, normally use 5 workers, and then normal finish time is like 10 days. But if we use more workers, like 6 workers, 7 workers, like that, then maybe the activity time, completion time of activity is shorter. So using more resource, then if using more resource, then if we can reduce the time, make it shorter, then use more resource. So cost high and then time low, like that. So find the least cost and then least time, completion time, using this time cost model part. Example, A, B, C, D, only 4 activities, and then immediate predecessor. Here, normal time, normal cost, and then crash time and crash cost. So using crash cost, like use more resource, then crash time, use $10 more, then time crash 1 day by 1 day, more use more resource, like $18 more, then activity B, 2 days can be shortened, and so on like that. So using this normal time, normal cost, crash time, crash cost, then in activity, this path is a critical path. So if we use more resource, so use more resource, then time increase the cost, but time decrease. So use more resource in activity D. And then again, activity D, more resource, then shorter, and so on like this. So next step is now B, use more, and so on. So step by step, use more resources on D, D, B, A, and so on like that. Then later, even if we use more resource, time, there is no change on time. That case, just stop there, stop here, and then duration is then 5 days. So this, we call this crashing, using more resource, crash time shorter, like this. And then in real world, we use software, computer software, many popular softwares. And in academic area, mostly we use Microsoft Project. This time my computer is a new computer, so I didn't install that Microsoft Project yet, so I can show you how it works, but looks like this. So type in all information about activities, the name, and then duration of each activity, and then starting time, and then this one automatically start and finish time automatically, develop Gantt chart, and then automatically draw network diagram, and then this program calculate which path is critical, and they indicate by red. And this one gives certain information like early start, early finish, and so on. So using this software, we can manage project time and then project. Okay, that's all. Okay, that's all. And do you have a question? Okay. There is no individual assignment from this chapter, but by next week, any group project progress. So don't wait until last minute, just start your project. So you may develop introduction part like problem statement area, and then if you find a certain like a team for find any techniques or tools to manage that problem, solve the problem. Then so next week I will not give you specific like assignment, but any progress, I will ask you if you have any progress. Then based on your progress, I will give you comment. Okay, any question? Okay, sounds if good. You don't have, yeah.
Nope, sounds good.
Okay, good, thank you. Okay, if you don't have a question, that's all for tonight. You know, because I scheduled this class in class, so I made it short class relatively. But anyway, that's all, and see you next week. Have a nice and safe weekend, and see you next week.
All
See you,
right, thanks,
Dr. Kim.
Okay, thank you. Bye.
Thank you, Dr. Kim. Good night.
Good night.